Did you know the ground beneath your feet is constantly on the move? Right now, North America and Europe are drifting apart at about the same speed your fingernails grow. It might not seem like much, but over millions of years, this tiny movement has completely reshaped our planet. This is the story of continental drift, a revolutionary idea that took decades to be accepted. Back in the early 20th century, a German meteorologist named Alfred Wegener noticed something peculiar on a world map. The coastlines of South America and Africa looked like they could fit together like pieces of a giant jigsaw puzzle.
And it wasn't just the coastlines.
He found identical fossils of ancient reptiles like the Mesosaurus in both Brazil and South Africa. How could a land-dwelling animal cross the vast Atlantic Ocean? He also discovered matching rock formations and mountain ranges across continents now separated by thousands of miles of water. For example, the Appalachian Mountains in the eastern United States are geologically identical to the Caledonian Mountains in Scotland and Scandinavia. It was as if someone had torn a single mountain range in half. Wegener proposed a radical theory. All the continents were once joined together in a single supercontinent he named Pangaea, meaning all lands in Greek. He suggested that around 200 million years ago, this supercontinent began to break apart, and the pieces slowly drifted to their current positions. He called this process continental drift. It explained everything: the puzzle piece fit, the fossil distribution, the matching mountains. It was a brilliant, all-encompassing idea. But there was a huge problem. Wegener couldn't explain how the continents moved. He suggested that the continents, made of lighter rock, were plowing through the denser rock of the ocean floor, propelled by the Earth's rotation. The scientific community at the time was skeptical. Geologists and physicists calculated that the forces he proposed were nowhere near strong enough to move entire continents. They dismissed his theory, labeling him an outsider and a dreamer. For nearly half a century, the idea of continental drift was largely rejected and forgotten. Wegener tragically died on an expedition in Greenland in 1930, never seeing his revolutionary theory vindicated. The breakthrough came decades later, after World War II, with the development of new technologies that allowed scientists to explore the ocean floor in unprecedented detail. Using sonar, researchers began mapping the seabed and made a stunning discovery: a massive, underwater mountain range snaking around the globe like the seam on a baseball. This is the Mid-Atlantic Ridge. What was even more surprising was what they found happening there. Scientists like Harry Hess and Robert Dietz proposed a new theory called seafloor spreading. They suggested that at these mid-ocean ridges, molten rock or magma from the Earth's mantle rises to the surface. As it cools, it forms new oceanic crust, pushing the older crust away from the ridge on either side. It was like a giant conveyor belt, constantly creating new seafloor and pushing the continents along with it. This was the missing piece of Wegener's puzzle. The continents weren't plowing through the ocean crust. They were riding on top of it as it was being created and spread. Further evidence came from paleomagnetism, the study of the Earth's magnetic field recorded in rocks. Scientists discovered that the Earth's magnetic poles have flipped many times throughout history. When new volcanic rock cools at the mid-ocean ridges, magnetic minerals within it align with the Earth's current magnetic field, like tiny compass needles. This creates a pattern of magnetic stripes on the ocean floor, mirrored perfectly on either side of the ridge. This symmetrical pattern was irrefutable proof of seafloor spreading. The ocean floor was a historical record of both its own creation and the flipping of Earth's magnetic field. These discoveries led to the development of the modern, all-encompassing theory of plate tectonics. This theory explains that the Earth's outer shell, the lithosphere, is not a single, solid piece. Instead, it's broken into about a dozen large, rigid plates and many smaller ones. These tectonic plates are all moving in different directions and at different speeds, floating on the semi-molten layer of the upper mantle beneath them, called the asthenosphere. The continents are embedded in these plates, so as the plates move, the continents move with them. Plate tectonics is the engine behind continental drift. The movement of these plates is driven by convection currents in the mantle. Hot, less dense material rises, cools, and then sinks, creating a slow-moving circulatory system that drags the plates along. Think of it like a pot of boiling water, where the heat from the bottom causes the water to circulate, moving anything floating on the surface. So, where the plates move apart, like at the Mid-Atlantic Ridge, we get divergent boundaries. This is where new crust is formed, Where they collide, we have convergent boundaries. Here, several things can happen. If an oceanic plate collides with a continental plate, the denser oceanic plate is forced to slide beneath the lighter continental plate in a process called subduction. This creates deep ocean trenches like the Mariana Trench and fuels volcanic activity, forming mountain ranges like the Andes in South America. When two continental plates collide, neither can be easily subducted. Instead, they crumple and fold, pushing upwards to create massive mountain ranges like the Himalayas, which are still growing today as the Indian plate continues to crash into the Eurasian plate. Finally, where plates slide past each other horizontally, we have transform boundaries, like the San Andreas Fault in California. These are hotspots for earthquakes as the plates grind against each other, building up stress that is then suddenly released. So, plate tectonics doesn't just explain continental drift. It explains almost every major geological feature and event on our planet. It explains why we have earthquakes, volcanoes, and mountain ranges in specific locations around the world, often along the plate boundaries, a pattern known as the Ring of Fire around the Pacific Ocean. It explains the formation and destruction of ocean basins. It is the grand unifying theory of geology. The movement is relentless. The Atlantic Ocean is getting wider, while the Pacific Ocean is shrinking as the plates surrounding it are subducted. East Africa is slowly splitting apart along the Great Rift Valley, which will eventually form a new ocean. In the distant future, perhaps 250 million years from now, scientists predict the continents will once again merge to form a new supercontinent, sometimes called Pangaea Ultima. The world map we see today is just a snapshot in a very long dynamic history. From Alfred Wegener's initial, ridiculed observations about matching coastlines and fossils to the modern understanding of plate tectonics, the story of continental drift is a perfect example of how scientific ideas evolve. It's a reminder that the solid ground we stand on is part of a dynamic and ever-changing planet, a massive geological dance that has been going on for billions of years and will continue for billions more. Thank you so much for watching. If you found this journey through time and geology interesting, please give this video a thumbs up and subscribe for more explorations into the wonders of our world. See you next time.